Alrighty, let's go ahead and get started. So exciting. Okay, I will be calling the names like your teacher already does. I've already learned quite a few of your names, but how do we pull up the? How do we pull up?
Oh, I hit the pause button on the bottom.
Oh, perfect. One more. There we go. Yay. Okay, perfect. So today what we're going to be doing, as you can see, is talking about arc length. Now this whole time we've been talking about degrees of arcs, right? You are all similar things like this, like if we have an angle like this, like if we said this was 90 degrees, we know from the rules that we've learned that this is 90 degrees, right? What we're going to be looking into is length. Now, Trey, when I say length, what do you think of? What measurements do you think of? How long something is, right? You're thinking of like inches and meters. Great. So in this case, are degrees a source of measurement, like a way to measure things? They are, right? But it's not showing how long something is, right? It's just showing how open. It's showing an angle. So that's what we're going to be getting started today. Perfect. All right. And then let's start using names. Silas. What's up, Silas? Can you remind me what the formula to find circumference is?
What is it? Arc?
I know you know it. You know off the top of your head, dude.
Circumference equals pi times diameter.
Times r times diameter?
No, pi times diameter.
Yeah, that's what I'm perfect. We have pi times diameter. What's the same as diameter? 2 times the radius, right? 2 times the radius times pi, 2 pi r. It's however you write it. They're the same thing, right? And the reason we're going to be talking about this is because suddenly we want to talk about the arc length. And when we're thinking about arc length, we want to think about a portion of the circumference. And we say this because when we're looking at a circle, and if we want to find the length of this arc here, it's going to be this part here, that's a portion of our entire circle, right? Portion of the circumference is the arc length. So what I'm going to do here is I'm just going to talk aloud. I'm going to think aloud the steps to figure this out because there's a formula for this, but I don't want to just tell you the formula. I want to show you how I'm thinking through how to find it. So maybe to give a little scenario here. I have a pizza. Raise your hand if you like pizza. You guys like pizza? A lot of people like pizza. I have pizza like 2 times a week. Not even joking. It's super easy to make. I also worked at Peter Piper Pizza, so I've done a lot with pizza. You can cut it in so many different ways, right? This is a pizza that has 8 slices. It's not perfect. But I'm sure you're all familiar with fractions. If we're looking at a section of it, we can say, okay, that's 1 piece out of 8 total pieces, right? Because there's 8. Let's see, what if we did this? Just an easy review for you guys. Do I have Jace?
Yeah.
Yeah. What would you say this piece is?
1/4.
1/4. Why is it 1/4?
Because there's 4 quadrants.
Exactly.
It's one of the 4.
Yeah, 4 pieces. Perfect. You guys know this. You already know all the background information you know to start this formula. Okay? So in this case, instead, we're looking at degrees. Can someone tell me what the total degrees of a circle is?
360.
Oh, some guy. Yeah. Were you gonna say 360? 360. So in this case, I'm like, okay, I've got this piece. I have 40 degrees of this piece. So I'm gonna say, okay, yeah, blue. So we have 40 degrees out of 360 degrees. That's us saying, okay, we're taking this central angle and making it a piece. Do you have a question? What was that? Oh, okay. So, all right. Was it Andres? Right? Yeah? Oh, Amari, that's right. Can you tell me what 40 divided by 360 is? Do you have a calculator with you? No? Does someone have a calculator out? so we have 1/9 of this pizza, as you can say, right? But now I'm like, okay, well that could be any size pizza. We could have a pizza with 12, like it could be a giant 24-foot pizza, right? We don't know. And that's why we need the circumference. That's why we reviewed it here. We have 2 pi r, right? And look, they give us the radius. If it helps you, maybe list on the side. Okay, they gave us an angle of 40 degrees. They gave us a radius of 18 centimeters. Notice centimeters, we like that. We want length. We need to pay attention to that. So in this case, I want to use my circumference, which we already said is 2 times pi times r. Okay? So now if we just bring that down, can someone tell me what 18 times 2 is? 36. Woo! You guys are on fire. 36. And we bring down the pi, right? And now we just multiply across. 36 divided by 9. Is that 4? Yep. You guys are doing awesome. I know I can call on you more. I know some of you like to just call out. Okay. Well, what is this telling us? Suddenly we found the length of that arc. What I want you to recognize is we're taking a piece of the circumference. That's all it is. Piece of the circumference. Try.
How do we get 4 pi?
Great question. Let me rewrite this a little better so you can see it. Because that is an important thing to know. So we got this and we got it to 1/9, right? We just divided. 40 divided by 360 is 1/9. And then we just brought down the circumference. So that's 2 pi, or we said it was 36, right? 36 pi, so we multiplied 18 times 2, and that's just over 1, right? If it's just a whole number, it's over 1. So I multiplied across, which in this case is 36 pi over 9. So I just skipped a step, I just simplified it. And so we said that, when you simplify it, is 4 pi. Yeah, does everyone see that? Okay, now I'm going to tell you what the formula is, which I think you already can recognize from what we talked about. We want the central angle over 360, right? That's the piece of the pi. And we're multiplying that by the circumference. If you like 2 pi r, or if you like diameter times pi, whatever works for you. All you need to see is we're getting a piece, yes, it's France circumference. Piece of circumference. That is where this comes from. So if you're not sure, I don't remember the formula, just remember, piece of the circumference. Just trying to ingrain it in your head. Okay. Well, cool. Give everyone a little bit longer. And notice when it says central angle, this here, we call it a central angle because that's the one that's attached to the arc that we're looking at. If they gave us this angle here, we would have to do some math to get around to find the central angle. So it's not any angle you see, it's the central angle, okay? Okay. And then, if this helps you guys, this is something called a Frater model. Many other classes, especially English, does this for vocab. So if it's helpful for you guys, on your packet, just to help you recognize what it is, you can draw this little box. You can either draw at the top here, bottom here, wherever you have space, just draw this little model. This is something that my teachers have shown me is really helpful. So it can just ingrain in your mind, what is arc length? Can someone tell me the definition of arc length that we just wrote down?
Portion of circumference.
Portion of the circumference. Circumference. And a picture, that's what this one is. I didn't even tell you what these are. Definition, picture, example, and non-example, right? So a picture could be, okay, we got this little piece, and then we want the length of that, right? An example could be, oh, AB equals 13 centimeters. non-example would be AB, viewers, 60 degrees. That is not the arc length in this case. We want the length, right? This is the degree, this is the length, okay? Degree. That is different. So you've learned all sorts of rules with these, but we're going to be using it a little differently now. Okay? I'll give you a second. If you guys want to finish writing that down, you guys are fantastic. Love it. Okay. So it looks like everyone's caught up. So now we're going to go on to the next question. Okay. Oh yeah, I drew it. I forgot. Perfect. Okay. So I need help to set up this problem. Is Shay here? Hey Shay. So this says find the length of the arc of a circle with a radius of 8 and a 30-degree arc. That's a lot of words. We don't have a picture. Can you help me draw it, Shay? Can you tell me what to draw? Radius of 8. Okay, 30-degree arc. I'm gonna use a different color. And I'll just choose a random spot here, because that's similar to the one you saw. Okay, so this is 30 degrees, right? I hope everyone is following along in your own papers, drawing them as well. All right. So then, do we have Alyssa here? Alyssa, hey, do you know what the first step is from what we were doing before? Thinking about pizza. Oh, 30 by 360. Why are we doing that? What was that? You don't know. That's okay. We're working through it. So, is 360, what significance does that have with this circle? It's the whole circle. So we're just finding a piece. That's great. Thank you, Alyssa. We're finding a piece of the circle, right? Just helping you understand the process. 30 degrees. I mean, 360 is what Alyssa said we were going to do. Okay? All right. Let's ask for Julianne. Can you help me know what to do next? By 30 by 360. Let's do it. Do you know what that would be? Just 12? 1 over 12, right? Because we have a fraction, right? Don't be scared of fractions. They're more scared of you than you are of 1 over 12. Okay, so we just simplified that expression. Thank you so much. All right, is Devin here today? Okay, Devin. Can you tell me what would go on the other side of this equation? 5 times R2? Yeah, the order doesn't matter in this case, right? So we will find. Thank you so much. And how do you know what R would be? Because the radius is 8. Okay. Fine. Okay. Well, perfect. And then Devin, do you know what this would be? Using spider 65. All right. And then Trey, what would this become? Or 60 divided by 12, right? 12. Okay, and then if we were to simplify that, they're each divisible by 2. All right, we did 2. Then it would become, I'll do a different color so we can separate it. So then we have 8 pi over 6. Can that be simplified anymore? One more? By what number? 2. All right. Divide by 2 again. We have 4 pi over 3. Yay! We did it! Okay, so just seeing, we're recognizing those steps. Okay. Ooh, there's a extended page one. Oh, I love it. I love it. Okay, perfect. This is where we're going to do something a little more interesting. Okay. So, this problem here on the bottom of your packet is a little different than what we've done. It says a bike with a wheel that has a 24-centimeter diameter goes around 10 times, okay? How far has the bike traveled? The first thing I want you to do is you're gonna spend 30 seconds thinking about this. You can write it down and then you're gonna talk to a partner about it to see your reasoning. I want you guys to think about it, because this is a different problem than when we did before. It might be easier for you, actually, or it might be harder. The point is I want you to think about it, right? In your mind, what makes sense. Do we need to use any of the stuff we had before? You know? So, what we're gonna do, I'm gonna pair these two rows together, these two rows together, these two rows together,
Alright, y'all.
and then you two
What we
together.
think?
Basically what you do, so wait, before you start, each of you has one person you're talking to, okay? But the first thing you gotta do is think for 30 seconds, right? So I'm gonna count to 3, you're gonna think for 30 seconds, and then the person with the longer hair will start first in the discussion, okay? So, 1, 2, 3, you're gonna start thinking for 30 seconds, ready, go. Maybe in your head. And you can write on your paper if you want. Start jotting down ideas. This is called a think, compare, share. Okay, now I want you to turn to your partners and share your thoughts. And you're going to do that for 1 minute. Ready, go.
I just thought it was like
Not you knowing this.
I mean, it's 212 for your shoes. Guys writing down your answers? Okay. Alright, looks like everyone's done talking. Okay, raise your hand if you feel confident in your answer. We have some confident people. Can you come up and show us what you're thinking?
Got
You
it,
can
guys.
take the markers. It's kind of cool. I like it. I lost. Okay. Here you go. So you can draw, you can write. Tell me what you think, and we're gonna help you out if we get stuck.
Okay, so as she draws it out, so we were basically just like, it's kind of like.
Okay, because the diameter, it's the diameter.
And
So
it's
it's only
24.
there is 24.
And it's like, tell me just like
If it's going around 10 times, it would be 24 times 10.
which is 240 centimeters or 20. That's what we got.
Okay. Did anyone else get something different or have any thoughts there? Because I think there's more we can do that. Oh, who said yeah? Who said yeah? What do you think? What can we add?
I feel like you need to do like the same thing you did up top, but they need to multiply it at 10 again.
Multiply by what?
By 10 because you're doing it like 10 times, you know what I
We
mean?
did. 24 times 10.
No, but like don't you need to like cut it in half because you only use like the radius and stuff like that?
Big red.
I think there's one element we're missing, because we're only paying attention to the diameter here. What about the whole circle?
Oh, we get to
Mm.
we get to find it.
Do we need to focus on degrees? We need to find the circumference. Why do we need to find the circumference?
Because that's the entire.
It's the entire circle, right? It's the whole tire we're looking at. It's not just the diameter, it's the whole tire. So what would you change?
The diameter.
So what would you do?
24.
No, the radius is 12.
So then 24 pi times 10.
You don't need the radius. You need to find
25 times 10.
Yeah.
the outside length of the circle.
Yeah.
Oh yeah, you use your hand like a foot. Oh. Do that.
What did you need to find the circumference?
I will explain.
The radius and the
Shut up.
diameter.
Stop shutting me.
Okay, so as soon as they're done, we're gonna bring this back together and talk about it a little bit. Because this is nothing like the one we did before, right? Why am I doing this? That's the question.
Well, we gotta just one day kind of do like.
Move your circle.
So,
Oh my god, you got 24 pi equals, equal, well, not that, but it has a
why we used circumference in this case, not just the diameter. It's the entire circle. Silas, do you have any
The whole
thoughts?
outside of the circle just rolls on the ground.
Right, so suddenly, you bring everyone back real fast. I know all you see is a circle here, but what if we took the circle and we cut one of the ends and we spread it flat? Suddenly this circle becomes a line, right? It's rope, I know. If you take a string, it's a little easier, but the visualization is where it's at. This is what we're turning it into, right? We're just finding the length, right?
So like you do 24 divided by 2.
24 divided by 2 gets you the radius of the circle. But you can use that too. You can use that to find circumference. And then all we literally did is multiplied it by 10 because this whole thing, the whole wheel is rolling 1, 2, 3, 10 times. Does anyone have any questions? Grace, do you have a question? No? You're good? Okay. The whole reason we did this is because it takes time to read a question and to see what pieces you need. We didn't use any of the degrees or anything earlier because it wasn't necessary, right? When you're in tests and exams, it's important to just pay attention to what do you need, right? Okay. Hey, that was great. Thank you guys. I think we can have everyone come